Hello, I wanted to give everybody a quick update. Hope everybody had a good fall break. Um, First off, the gradebook has been updated. Everything has been graded. I went through the test online for my stat lab test and went through and ordered partial credit where I thought I could. And if you have any questions on that, please let me know. The calculated grade is correct in D2L, so make sure you check that. If you have any questions, let me know. I mean, the formula for that, right, is that we have the projects, and so we have the project average, and that's worth a total of 200 points total. And it goes ahead and weights it as if you've done all the projects, even though we haven't. So that's why there may be a slight discrepancy if you just try to add up your total points divided by the points possible. So a project is over 200 points. So whatever your project average is, just multiply it by 2. And the midterm as well, it's assuming you've already done both the midterm and the final, and you haven't. But it weights that's a test category, so it weights it as 200 points. Okay, everybody's doing great in here, so keep up the good work. One of the things is that we finished chapter 12, which is on sampling and types of surveys and the types of conclusions you can reach from experiments and observational studies. We're skipping a bunch of chapters. So what are all those about? Those are about probability for the most part. And we are skipping most of those. You can kind of get lost in the weeds in probability, and it's frankly not as important as for statistics as it used to be. We have so much computing power now that we don't need it. The one big idea from probability I want you to get, and I'm hoping you're watching this video, and if you're watching this video, you're watching the video. So is the law of large numbers. So we all have a sort of a sense of what probability is. For instance, here is an applet. We are flipping a coin one time with the probability of heads at 0.5. And so if I run this, just one time, there's my head. We'll close it. Let's run it 5 times. And it's going to give me a probability here. So in this case, we have only one head, it appears. So what I want to do is, so the probability here of a head is 0.167. But we know the probability here is really 0.5. So what does this probability mean? If we do this several times, let's run it 5 more times. Let's run it 5 more times. We can kind of see what's happening here. Let me go and run it 1,000 times. That as we increase the number, the n, the number of tosses in this case, it actually is going to approach the probability, the theoretical probability. And we can kind of see that with our graph here. And we can look at the proportion. It's 0.5079, very, very close to 0.5. Let's look at another one with simulators. So this is a dice company, Lucky Town Dice Company. We want to simulate rolling dice. So like if we roll it once, there's a roll and the person got a 2. Roll it again, we get a 5. Hard to know what's happening. Let's do it 5 times. With dice in particular, we probably need to do this several times. Let's go ahead and run it 100 times. We didn't get any 3s. We don't find that super odd, right? Or 7 rolls. That's not super unlikely to happen. But if we roll 100 times, and if we didn't get any 3s 100 times, then we'd be a little questionable, right? So what do we notice here first off? What sort of stands out? Yeah, a whole bunch of 6s. Let's do this maybe a total of close to 1,000 times. So it appears that 1 through 5 are roughly even. I mean, not 100% sure about number 5, but look at the number of times 6 comes up. Number 6 comes up considerably more than 1, 2, 3, 4, or 5. So our long run probability is about 24% or 0.24 for getting a 6. And that's what probability means. And so they will be referencing probability in our later chapters. And that's all we're thinking about when we think of probability is the long run likelihood of obtaining that value. Okay, so that's all you need to know probability for this class, really. We are also skipping another chapter that's actually pretty important theoretically, but we don't have to actually know that to run our computation. So I've decided to do a minute this time. This is the first semester I'm using this text, so we'll see how this goes. But I do want to give you a sense for what it is. It is optional in the book, so you can do some of the homework on there if you need to. Really what this involves is sampling distribution. So imagine this as a population, very normally distributed, right? And if I took a sample, let's say I sample at one time, take a sample of size 2, I might get something like that. Let's do this sample of size 2 5 times. We can kind of see it's going to cluster around. Here's our samples. They're going to go around, and then we find the mean of those two, and it'll drop down here. Let's do it 1,000 times. And probably no surprise that the distribution of sample means is in fact normally distributed. Let's in fact increase this sample size, because usually when we are collecting data, we're collecting data with maybe a sample size of, let's say, 20. We go out and survey 20 people and do this as well. So let me just go ahead and do it 1,000 times. Again, no surprise. We get a nice, fairly normal distribution. But what else do we notice? We notice that this is tighter around the mean. So as I increase my sample size, the variability of this distribution gets much smaller. In fact, let's go ahead and just prove this. Let's do 50. Hard to tell here because everything was so spread out. Let me go back to, let's do 5. Okay, so we see 5 stretches out between, around 16 or so and 32 or 33. And now as I increase that, 20. It's much tighter, right? Okay, so let's just keep it at 20. Probably no surprise, again, that it was from a normal distribution. But let's say I had a different kind of distribution. Maybe I had something like this. And you can do this in StatCrunch yourself. I recommend doing that. Where would you do that? If you go to Applets and Sampling Distributions. Okay. What kind of distribution is this going to get if I sample it? And let's just do it, let's do it 5 times and see what happens. There's 5 times. It kind of clusters right here. Let's do it 1,000 times. Whoa, did you expect that? We have a nice normal distribution. This is the central limit theorem. This is key to our ability to analyze data. Again, why we've been working with normal distributions for a big chunk of the course is because of this. Is because almost no matter what sort of distribution I have, when I take a sample, it's going to end up being normal, so long as n is fairly large. Now, if I only took a sample of 5, it's going to be much spread out, and you'll sometimes get some bimodalness going on. Again, we can get some crazy distributions, and yet still we're going to get a roughly mound shape sampling distribution. So this is what allows us to run all of our statistical tests. Okay, you can accept it on faith, but boy, it's really nice if you can kind of get a sense for how that works. Okay, so you can go through the homework and read through the book on that. There's some really good theoretical stuff here, but you don't have to know all that to end up working through many of the problems that we'll do. So our upcoming assignments, the course statistics, if you ask people to teach it, are kind of split in half. We have the first half of the course, which is mainly descriptive statistics, mean, median, mode, types of statistical studies, and we also did a little bit of regression in there. And then the second half of the course is going to be inferential statistics. That's kind of why I try to split it the way I have, where we make inferences based on our collected sample. So far we've just been kind of analyzing our sample. But why take a sample? We generally want to take a sample in order to make an inference to the entire population. Okay, because we often can't sample a whole population. We learned that in an earlier lesson. So chapter, I believe 19 in this text is going to be on confidence intervals. We're in election season right now, and you're going to be seeing lots of polls. These are basically just confidence intervals. Well, they are confidence intervals. Often they're doing 1 prop or 2 prop Z intervals. And that's what we're going to be doing, 1 proportion Z interval in chapter 19. And then we're going to look at hypothesis testing, a big and very important, meaty part of the course. Okay, so there are no related research articles due in the next week or so. Check your due dates on all that. But we're going to do confidence intervals and hypothesis testing throughout the remainder of the course. So make sure that you get that. We're just going to be looking at different types of parameters. So we'll look at proportions to start off with, and then we'll look at means, and we'll turn ourselves to the t-test, and then we'll start looking at 2 samples, and then we will look at categorical data again, looking at a chi-square test. And then finally, I believe we'll finish with the ANOVA, when we're looking at more than 2 means. So a lot of good stuff coming up, so hang in there. You guys are doing great. Look forward to working with you. If you have any questions, just let me know.